Hello my dear students, welcome back to NEET World. So today in this session we will be discussing electrochemistry. See, when it comes to electrochemistry, so this chapter I have already covered in the this channel itself, okay. So now here what I am going to discuss, see, we will be covering complete chapter using PYQs of NEET, JEE and EAPCET exams, okay, so that you will feel more confident about solving the questions from this chapter, okay. So right, so look at the first basic question here. First of all, see this question, what the question says here. See, how many Faradays are required to reduce 1 mole of permanganate ion to manganese ion? It means KMnO4, or here it is just MnO4 minus ion is given, okay. Now this ion converting into Mn plus 2 right now. So in this process, how many Faradays are involved, they are asking. See what is happening here, plus 7 oxidation state converting into plus 2. So how many electrons involved? Number reduced or increased? Reduced now, oxidation number 7 is converted into 2. So it means by gaining 5 electrons, this transformation is observed. So it means how many moles of electrons are involved here? 5. See, for conversion of 1 mole of this permanganate ion to 1 mole of Mn plus 2 ion, it requires 5 electrons, okay. Now there are 5 electrons involved, okay, like 5 mole, like for 1 mole 5 moles of electrons are involved. So charge of 1 electron is how much? 1.602 into 10 power minus 19 coulombs right now. So the charge of 1 mole of electrons, 1 mole means what we can write, Avogadro number now, 6.02 into 10 power 23. See this number, see upon solving this we are going to get a number, that is how much? 96500 coulombs. How much? 96500 coulomb. So this number is called Faraday. What we can call this number? Faraday. So the charge of 1 mole of electrons is called 1 Faraday. Like that, how many Faradays are required now? See, 5 electrons now. So 5 moles of electrons now. So 5 Faradays are required. So how many Faradays are required here? 5 Faradays. Now do we have that option here? Yes. Fourth option 5 is there now. That is your answer for the discussion. Okay. Next. By the same way, now tell me there is AlCl3 solution, okay. So now from this electrolytic solution I want to deposit aluminium metal, okay. So from 1 mole of AlCl3 solution I want to deposit aluminium. Now tell me how many Faradays are required for this process? Yeah. Now what is the oxidation state of this aluminium here? It is plus 3. Now plus 3 should convert into its atomic form, that is 0 oxidation state. So conversion of this 1 mole of substance, how many Faradays are required? See, 3 is converting into 0 means 3 moles of electrons are required. So 3 moles of electrons is nothing but 3 into 1 mole of electron value is this much, charge of 1 mole of electron. So it is 3 Faradays. Okay, is this clear? Now I am saying, instead of saying 1 mole of this, 1 mole of aluminum is nothing but how many grams? Aluminium atomic weight is 27. So by passing 3 Faradays of electricity, we are going to get 27 grams of aluminium, okay. So now during this conversion they will say only 9 grams of aluminium is deposited. Then how many Faradays is supplied? What I am saying, for 3 Faradays, upon supplying 3 Faradays, we got 27 grams. Now what I am saying here, only 9 grams of aluminium is deposited. So how many Faradays are supplied here? 1 Faraday. Just what is the conversion from here to here? Divided by 3. So here also you divide it with 3. So that it will gives you 1 Faraday. Okay, is this clear? So just remember one thing, I will tell you one simple way. Shruti sir, question is not visible. Yeah, let me show it once again. Yeah, now I hope it is fine, right? So now I will tell you one simple way to solve this kind of questions. See, upon passing 1 Faraday of electricity, okay, 1 Faraday of charge, you are going to deposit 1 gram equivalent of that substance. What I am saying, 1 gram equivalent of substance. For example, upon passing 1 Faraday of charge, you are going to get, see, Na converting Na plus like sodium chloride is there. From that we are depositing sodium. So now by passing 1 Faraday, what is the charge here you are seeing? So it means by passing 1 mole of electrons, we are going to get 1 mole of sodium metal. So that is, I can say 1 mole of sodium metal or 23 grams of sodium is deposited. Okay. Now similarly there is magnesium plus 2 like MgCl2 solution is there. From this magnesium metal should be deposited. Now tell me how many Faradays are required to deposit? Yeah. So what is the charge here we are doing? Seeing plus 2 now. So it means plus 2 should convert into 0. So for 1 mole of this conversion, we require 2 electrons for each species right now. So it means 2 moles of electrons required or 2 Faradays are required. So 2 Faradays, but how much I am sending here? Only 1 Faraday. So this will deposit only half mole of magnesium it will deposit. Is this clear or not? Okay. Or I can say half mole of magnesium is equivalent to 12 grams of magnesium. Okay. Similarly, if there is AlCl3 solution, so to deposit aluminium, see plus 3 is converting into 0. How many Faradays are required? Plus 3 now. So 3 Faradays are required to deposit 1 aluminium, like 1 mole of aluminium, that is 27 grams of aluminium. But how many Faradays I am sending? 1 Faraday. So it deposit only 1/3 mole of aluminium. Okay, this is nothing but 9 grams of aluminium. Okay, so it means if these solutions, if these liquids, if these electrolytes are connected in series connection, it means if I pass same quantity of electricity, it will deposit 9 grams, this will deposit 12 grams, like that it will deposit 23 grams. Okay, is that clear? Okay, so the next one, I will show you a few questions. Can you answer me this? 1 gram of metal ion was discharged by passage of that many electrons. What is the atomic weight of element they are asking? See, it's very simple. 1 gram of this metal. See, metal charge is how much? Plus 2. That metal deposition means 0. So for this 1 mole deposition, we require 2 Faradays. Okay, so 1 mole deposition of that metal is nothing but 1 mole weight is nothing but its atomic weight only now. Atomic weight will get upon passing 2 Faradays of electricity. Now how many electrons are passed here? 1.8. So this is nothing but 2 moles of electrons are passed. Now here we want this much, but it is giving 1 gram of substance upon passing 1.81 into 10 power 22. Okay, so now what I required from this? I want its atomic weight. See, we can use unitary method now. What is that unitary method? Atomic weight into this number. Okay, these two things. Just multiply. So atomic weight into 1.81 into 10 power 22 is equals to 2 Faraday. That is 2 into charge of like Avogadro number now. Yeah. So 6.02 into 10 power 23. Okay. And this is Avogadro number. Why I am taking Avogadro number? They pass this many electrons. If I pass this many electrons, we are going to get something like this. Okay. Avogadro number. And charge of 1 electron is how much? 1.6 that thing. Okay. So here I can say atomic weight will be equals to now 2 into 6.02 into 10 power 23 divided by this number. So 1.81 into 10 power 22. So from here how much you are going to get? It is 10. Okay. Now atomic weight will be, so 60 into 10, 120 divided by 1.8. Okay. So this you just check, this is nearest to 2 now, but less than 2. It means 2 by 1, 120 by 2 means how much we will get? 60. See, look at the options. 66.7. Because it is less than 2. So what we are going to get? It is 66.7. This is your answer. Do you got what we are doing? Okay. So now what is a main thing to consider here? You first relate how many Faradays required to deposit 1 mole of that substance. 1 mole of that substance is nothing but its equivalent to its atomic weight. Okay, like that you equate first. Okay, you got atomic weight to Faraday's ratio. From the data given for 1 gram, this many electrons. For this much weight, this much charge is passed. So find this. Okay, you can use this unitary method to do the steps. Okay, is this clear? Or any confusion are there? If you have any confusion, ask me. Yes.
In Faraday, we using Avogadro number and electron
charge also, no? See, this side did I use charge? See, this many electrons means each electron has how much charge? 1.602 into 10 power 19 coulomb. This side also same charge is there, no? So charge this side, charge this side. Both sides can be cancelled. Okay? Like that. Fine. Next. Next here. Yeah. Can you try this question once? Yeah. Tell me your answer for this. See, what is the compound they have mentioned here? Iron to bromide. So it means FeBr2. This is what the compound they told. Even you don't need to worry about the compound formula also, because what is the oxidation state they mentioned? It is +2 for iron. Okay. So from this, the mass of iron deposited they are saying. See, if I have only Fe+2 ion, so it should deposit as Fe. Now, how many electrons it required for 1 mole deposition? 2 moles of electron, that is nothing but 2 Faradays are required. So 2 Faradays gives you 56 grams of that substance. 2 Faradays gives you 56 grams of that substance. Now look at this. They are sending 3 Faradays of electricity passed through the electrolytic solution. Okay. So if I pass 3 Faradays, what happens, tell me? This will be X now. Find the X value. So find the X value. So X will be equals to 56 into 3 Faraday by 2 Faraday. So this will be 2, 8. So 4, 2, 6, 8. 84 grams. Is this clear?
Yes.
Simple only now. Very simple. Okay. Now tell me one more question here. The weight of aluminium deposited by passing 3 Faradays of electricity through AlCl3 solution. Tell me, what's your answer for this? 27. How easy it is? See, from AlCl3 means Al plus 3 converting into Al. How many Faradays required?
3 Faradays.
So 3 Faradays. If I pass 3 Faradays, we will get 1 mole of aluminium. That is nothing but 27 grams of aluminium. Okay, up to here it is clear. Now what I am saying is, instead of passing 3 Faradays, I am passing only 2 Faradays. What happens, tell me? 27 by 2. See, 3 Faradays means 27. I am giving you only 2 Faradays. So it is X now. So X can be now 27 into 2 Faraday by 3 Faraday. So it will be 9 to the 18. 18 grams of aluminum is deposited. Is this clear? What we are doing? Okay. Now, if I pass 3 Faradays of electricity, charge through magnesium chloride, how many magnesium metal atoms are deposited, or how many moles it is deposited? Tell me. What I am saying, question? If I pass 3 Faradays through MgCl solution,
36.
so how it is? 3 Faradays I am sending. Magnesium plus 2 should convert into magnesium. For this conversion, 2 Faradays are required. So 2 Faradays gives you 24 grams. What I am giving here, 3 Faradays. So it is X. So X equals to 24 into 3 by 2 Farad. 36. 36 grams of magnesium is deposited. Is this clear? Okay. Right. Let's move forward. Look at this question. We'll do this question once. Okay. So during the electrolysis of molten sodium chloride, the time required to produce 0.1 mole of chlorine gas using a current of 3 amperes. See what they are producing? 0.1 mole of chlorine. Now try to get the relation between number of charges, like what is the charge required for deposition of this moles. Okay. So now what is the formula for charge? Charge equals to time into current amperes into seconds, that is time into I into T. Okay. I means current, that is indicated in amps. Okay, amperes, time in seconds. So units for charge is coulomb. Okay, this you remember. Okay, now what they are asking, this we will discuss again. Come back to the question, what they are saying. During the electrolysis of molten sodium chloride, the time required to produce 0.1 mole of chlorine gas. See, NaCl is there. So in this chloride ions are present now. So if one chloride ion undergoing electrolysis, it gives you Cl2 gas, that is half mole, because how many chlorines are there here? 1. So you are going to get half. Okay. So now here, if I take this as 2, you are going to get 1 mole of chlorine. Right now, is this clear? Okay. So minus 1 is converting into 0. So how many? If I pass 2 Faradays, because 2 into minus 1. Okay. So minus 2 charge now. So 2 charge is converting into 0. It means how many electrons are involved? 2 moles of electron, that is 2 Faradays. So if I pass 2 Faradays of charge, I am going to get 1 mole of that substance. Yes or no? 1 mole of chlorine gas. That is nothing but 22.4 liters. Anyways, they are not asking about volume. Okay. Now if I only pass 1 Faraday, 1 by 2 mole Cl2. Or if you want, you can take it from here itself. So I will get 1 mole of chlorine when I pass 2 Faradays. Okay. So how many moles of chlorine here they are produced? So for 0.1 mole, how many Faradays are required? See, 1 becoming 0.1, so 2 becomes 0.2. Just divide by 10. Okay, so this becomes 0.2 Faraday. So if I pass 0.2 Faraday, I am going to get 0.1 mole of chlorine. Okay, so this is what the relation first. Now what is the charge we got? 0.2 Faraday. So charge equals to I into T we know. So charge is how much? 0.2 into Faraday, 96500 coulomb. Now what is I value mentioned? 3 amperes. So time we are going to get, we need to find time. Okay. So here coulomb means what I can write? Amperes into second. What is that? Amperes into second. So time, current, amperes are cancelled. Now we are getting answer in seconds. All options are in minutes. Okay, try to convert into that form. So time is equals to 0.2 into 96500 by 3 seconds we got now. So 1 by 60 minute. 1 second, 1 by 60 minute you can write. Okay, because answer should be in minutes. Okay, so simplify this like this. So we are going to get this as 965 by 9. 965 by 9. So upon simplifying this, see 965 by 9. How much times? Easy now. See 9 is there, 900. 9 into 100 means 900. Extra 65 is there. Okay, around 6 or 7 will get now. So it means which one is the nearest option here? We have no need of calculating also. Like 100 times 9 means 100 times. Yeah. This one, see 65 is there ma, 9 7 is 63 na. So you will get around 107 point something. So where do we have closest option? Second option. Okay. So this will be the nearest option. Here we have 110. So option 2 is your perfect answer. Do you got how we are approximating without simplifying it? Yeah. Next. Yeah, let's move forward. Look at this question again. The density of copper is that much. The quantity of electricity needed to plate an area of 10 centimeter, 10 centimeter to a thickness of 10 power minus 2 centimeter using copper sulfate solution would be. See, first of all, what they are doing, you know, electroplating technique we will be using. Something like some ornaments will be there, they will say gold plated ornament like that, right now. Inside there will be normal metal, but on that gold will be plated. Okay. Similarly here it is copper plating. So we can say it is an electroplating method. Okay. So now what is the data they have mentioned? They mentioned about area and thickness. So area into thickness, like L into L. See, centimeter into centimeter. What we are going to get? Volume we are going to get. So now what is the volume we got? How much volume they covered? That is 10 into 10, 100 centimeter square, and this is thickness, length again 10 power minus 2 centimeter. Okay, so this both can become 1. So 1 centimeter cube. So how much volume they have covered in electroplating? 1 centimeter cube. So keep it aside. Now how much density it has? So density is 8.94 gram per centimeter cube. Okay. Now looking at the density and volume, we can do calculation for weight. The weight of substance deposited will be, now what is the density formula? Mass by volume, that is weight by volume. So I want weight, that is mass. So D into V. Now D is how much? 8.94 only, no? 8.94 gram per centimeter cube into 1 centimeter cube. So you can remove this. So how much weight they have deposited? 8.84 grams. This is the weight of copper deposited. Okay. Next. So why you are doing all these calculations means, yeah. See, we got weight, quantity of copper deposited. See, from Faraday's laws, what we have? Quantity of a substance deposited at an electrode directly proportional to the charge current passed through that electrolytic solution. Okay, the weight of substance deposited at an electrode is directly proportional to quantity of electricity passed through that electrolytic solution. Okay, so more charge, more quantity is deposited. That is what it says. Okay, so now look at here. What are the steps I am using? I got a weight of substance. Now I am writing this as Z into proportionality removed. I am writing as Z electrochemical equivalent, Q as I into T, because what they are asking? The quantity of electricity needed to plate an area of this much they are asking. Okay, so charge means I can say, what is the quantity they have covered? 8.94. See, if I give you copper sulfate, that is copper plus 2 ion, okay, so in order to deposit copper, how many Faradays required? 2 Faradays are required because plus 2 is there. So if I pass 2 Faradays of electricity, I am going to get 1 copper metal. That is how many grams? 1 mole of copper metal, that is 63 grams. Okay. Now how many grams we have deposited here? 8.94 grams is deposited. Right now? So how much charge it has? So now again use unitary method. X will be equals to 8.94 into 2 Faradays divided by 63. Faraday we can write in terms of coulombs. 8.94 into 2 into 96500 coulombs divided by 63. Do you got what we are doing here? Okay, right. So upon simplifying this, you will get the answer as 27172 coulombs. This is the quantity of charge we need to pass. Okay, do you got the steps what I have did? See, sometimes they will give you density. The similar model question asked in JEE mains previously, like giving the density, thickness. First we need to find weight of that substance. We know weight and charge relation like this. Okay, so weight of substance deposited depends on quantity of charge passed through the electrolytic solution. So 2 Faradays 63 grams. Only 1 Faraday 63 by 2 grams. It means charge decreased, weight also decreases like that. So based on that, this much quantity of mass is deposited. So it is X Faradays. So you can find X value like this. Okay, is this clear? Right. Let's move forward. Yeah, look at this question. 3 moles of electrons are passed through 3 solution in succession containing AgNO3, copper sulfate and AuCl3 respectively. The molar ratio of amount of cations reduced at the cathodes will be. So now at cathode what are the cations we have? From AgNO3 we have Ag plus. Okay, this is one solution, and from copper sulfate we have Cu plus 2. From AuCl3 we have Au plus 3. Okay, now how many moles of electrons are passed?
3 moles.
If we pass 3 moles, see, in order to deposit Ag plus 2 Ag, how many Faradays required? But how many Faradays they are giving you? 3 moles of electrons is nothing but 3 Faradays now. So if I pass only 1 Faraday, we are going to get 1 mole of Ag as per the equation. Okay, because only plus 1 charge is there, 0 we need to convert. So it means if I give you 3 Faradays here, so how many moles of Ag deposited? 3 moles of Ag deposits right now. Now here you check. So to deposit copper, how many moles required? 2 Faradays of electron, 2 Faradays of charge is required. But how much quantity they given? 3. So now what we can do? See, if I pass 2 Faradays, we'll get 1 mole of that thing. They have mentioned 3 Faradays, I will get X moles. So X will be 3 Faradays by 2 Faradays. 3 by 2 moles of copper is deposited. Is this clear? Okay, now tell me here, in order to deposit Au plus 3 to
1
Au. Okay, how many electrons required? 3 moles of electrons, that is 3 Faradays. So by giving 3 Faradays, I will get 1 mole of Au. So you got now, so it is giving you 1 mole electron. Now what is the mole ratio we have? Ag Cu is to Au plus 3 plus 2. Now tell me, or just take metal, it's only. Now what is the ratio? This is 3 is to 3 moles is deposited now. 3 is to 3 by 2 is to 1 mole, like this. Do we have any option like this? No, but try to convert it in the possible ways. See, now what I am doing is, there are different possible ways here. I am dividing complete equation with 3, complete ratio with 3. So now what happens, this is 3 by 3 3 by 2 into 3, this is 1 by 1 by 3. So 1 is to 1 by 2 is to 1 by 3. Do we have like this? Yes. Second option is there. Okay. Now try to do this in one more way. One more way. So what is a denominator here we have? So now I am trying to convert these into normal numbers. Okay. So what I need to do, remove this 2 I need to remove. So for that what I need to do? Multiply complete numbers with 2. So it is 2 3s are 6 is to 3 by 2 into 2 means 3, just 3. So here it is 2, 1 into 2, that is 2. So 6 is to 3 is to 2. So we have two options. If I do it like this, we will get 1 is to 1 by 2 is to 1 by 3. If I do in this manner, 3 is to 6 is to 3 is to 2. So what are the options we can get here? 2 and 4. So these are the two options you can go with. Okay, is this clear? Yeah. So if possible, try to make a note of it. This is from our module only. Okay, there is a question. Okay, but is this concept is clear? Yeah, let's move forward with few more questions. Look at this question, what it is saying, once read it. What it is saying? The standard free energy change delta G naught for the following reaction is. So it means Gibbs free energy change they are asking. Okay, how do we do that? What is the relation between standard Gibbs free energy and potentials? Delta G naught is equals to maximum work done, that is minus charge into potential, that is minus NF E naught cell. This is the relation to be used here. Okay, right. So now first of all we need to know what is the E naught of this cell. How to calculate E naught of this cell? What is the cell they have given? Calcium Rm plus 3, converting you calcium plus 2 and Rm metal. Okay, gold. So now for this E naught cell, how can we write? E naught oxidation potential, reduction potential we need to know. E naught cell. So who is undergoing oxidation here? Calcium is undergoing oxidation. So what is its oxidation potential they given? See, you simply take it as E naught oxidation potential plus E naught reduction potential. Okay, but here what they given?
Reduction potential.
But what it is undergoing, what it is happening here? So take negative of it. Minus 2.87 is there.
Into minus.
So it will be 2.87 plus like gold is undergoing reduction. So its reduction potential value is 1.50. Okay, right. So this will be 7, 13, 4.37. This is the cell potential we got. Okay, what about number of electrons involved? Check once from the equation. How many electrons involved? See, calcium metal converting from 0 oxidation state to 0 to plus 2. Here 3 is converting into 0. How many electrons are involved? There it is 2, here it is 3. Are they equal? No. You need to equalize them. So 2 into 3 or 3 into 2. So total electrons involved 6. Okay, 3 2s are 6 or 2 3s are 6, like that. So N value is 6 and F is 96500 coulombs. And what about 4.37 volt? Okay, now if you look at the options, there are something like this. Now definitely we got a negative value, so you can remove BD, only AC will be your answers. Okay, from these what I am writing, okay, so what I am writing here, see, minus 6 into 96500 into 4.37 into coulomb into volt we have. See, coulomb into volt is there now, you can say this as joules. What you can say? Joules. Okay, they are asking you in kilojoules. But what we got? Remember this, charge into potential, that is nothing but work. That is charge into potential, you can say in terms of joules. Okay, Gibbs free energy means it should be in joules. Okay, they are asking in kilojoules. So what I need to make, 6 into 96500 into 4.37 kilo now, 10 power minus 3 you put, and kj. So k means 10 power plus 3, this is 10 power minus 3. Overall it will be j only, like joules, like that. Okay, so here minus 3 is there, so I can write these 2 zeros removed like this. So what we got, minus 6 into 96.5 into 4.37. Okay, now look at the option, both of them are 2.53 only, so 4.37 now. So what we are going to get here is minus 24 into 96.5 means 2 10 power 4. Yeah, so definitely you are going to get 1 2 3 4 now, so it will be 2.53 into 10 power 4 will be your answer. Okay, kilojoules. Okay, like this you can solve it, simplify. Okay, so if you want, you just simplify that and verify whether option 1 or 3. This is 4.37, that's it. Okay, let's, so it's not, okay. Okay, you can do this. Let's move forward. Yeah, look at this question and tell me what's your answer. Yeah, try it once. The question says standard electrode potential of M conversion to M plus to the cell is 0.3 volt. Okay, this is the cell potential, standard electrode potential. So at what concentration of Cu plus 2 the E cell value becomes 0? What they are saying, E cell value should become 0. Okay, so now what I can write here, so E cell is equals to E naught cell minus 0.059, that can be considered to be 0.06 by N log concentration of products by concentration of reactants. What are the product formed here? Product side. See, during this reaction, what is the indication of this reaction? M converting into M plus 2, and here copper plus 2 is converting into copper metal. So look at this, what is the product side? Ions, M plus 2. If there is any atomic state, solid form, its activity is 1. So consider only Mn plus M plus 2 concentration here, and reactant side Cu plus 2 only. Do you got up to here what we are doing? Because M is a metal, its activity is 1. Okay, up to here it is clear. Now how many electrons involved? Plus 2 is converting into 0. 0 is converting plus 2. It means N value is 2. This is 2. Okay. The value at which what they are saying, E naught cell value becomes 0. At what concentration of copper plus 2? E cell value becomes 0. If I say this value is 0, E naught cell minus 0.03 log concentration of metal ion by copper plus 2 ion. Like this we can write? Yeah. Now if I can bring this side. So minus E naught cell equals to minus 0.03 log Cu plus 2. Now look at this. What is the standard electrode potential mentioned? So I can write here directly 0.3. So minus remove. This will be 10 times. Okay. So if I send this log this side, it becomes 10, like 10. So 10 power 10 it becomes, that is equals to concentration of M plus 2 ion, concentration of Cu plus 2. We can write it like this. Now they are asking what is the concentration of Cu plus 2, and they have mentioned concentration of M plus 2 as 0.1. So I can write this as concentration of Cu plus 2 is equals to concentration of M plus 2 is 0.1, that is 10 power minus 1, and this is in the denominator as 10 power 10. So I can write 10 power minus 1 plus 10 power minus 10, that is 10 power minus 11. So this is the concentration of copper plus 2 ion. So we have an option like this. Yeah, option C. That is your answer for the question. Okay. So every step is clearly discussed. Any confusions are there? No. But main thing is you need to get the approach, like what is the formula to be used. See, they are saying potential. Whenever they ask for potential, directly you should look at the Nernst equation. What is it? Nernst equation. What is Nernst equation? E cell equals to E naught cell minus 0.059 by N log concentration of product by concentration of reactant. That's it. Yeah, let's move forward. Look at this question. For the cell reaction, the EMF of the cell is. How can you do this? For the cell reaction, the given cell reaction, we have just now I told now Nernst equation. What to write? Cu is converting into Cu plus 2. So this concentration should be product side concentration. And here plus 2 ion is converting into Cu metal. This is reactant side concentration. So you will get E cell equals to E naught cell minus 0.059 by 2 electrons. So 2 log concentration of product by concentration of reactant. So just put that values in that and you will get one of these options. Okay, next let's move. First option. Tell me about this one, about galvanic cell or indaliate cell. What happens there? In the Daniell cell, Zn is converting into Zn plus 2, copper plus 2 converts into copper metal. Okay, this is spontaneous cell reaction they have mentioned. So during this cell reaction, what is the potential generated? E naught cell is equals to around 1.1 volt is generated. It's a spontaneous reaction, that's why this much potential is generated. Now, when an external voltage is applied, what they did? They are applying external voltage. Without applying any external voltage, this much energy is generated. Now they are applying external voltage onto the cell. Such that what they did, they applied external voltage which is greater than the cell potential, that is generated 1.1 now. So they might be applying greater than this value. So applied potential is greater than cell potential. Now what happens, current flows from where to where? Yeah, so normally current flows in normal cell, current flows from anode to cathode. Now it will flows in anode, that's it. Okay, wait. So electrons flows from anode to cathode. Anode to what? Cathode. What I am saying, electrons flows from anode to cathode in normal cells. Okay, and if electrons are flowing from anode to cathode, current flows from cathode to anode in reverse manner. Okay, so in normal cells, in Daniell cells, from where to where it will produce goes, electron is from anode to cathode. This is electron flow. Current flow will be cathode to anode. This is in normal cell, galvanic cell or Daniell cell. So this is extra voltage applied now, it becomes opposite. Okay, so it will be anode to cathode. So where do we have that anode to cathode? So now actually what is our anode here? Zinc rod will be taking, zinc sulfate. Here cathode copper we will be taking here. Okay, so generally it should be from here to here electron flow, and from here to here current flow. Okay, in normal cell, but here external voltage is applied more now. So now what happens? A reverse from zinc to copper. So from zinc to copper. So this is your answer. Like that you need to understand the thing. Next, let's move. Just they are asking what is the proper cell representation for this. See, H2 is converting into H plus. What is happening? Oxidation. Okay, oxidation takes place at anode. First anode half cell, then next cathode half cell. So anode H2 is converting into H plus, that is acid. That is fine here. Here also fine. How this KCl came here? No. Here also KCl is there? No. Out of these two, no. Okay. So now AgCl solid form converting into chloride ion. Okay, so chloride ion, so AgCl converting into Ag, AgCl converting into, this is AgNO3, no, so here it is perfect now, so you can go with option. Okay, next, let me show you few more questions. Look at this. Which are the following galvanic cells EMF is maximum? So how can you try this? What is EMF formula? Like from Nernst equation we have na, E cell is equals to E naught cell minus 0.059 by N log concentration of product by concentration of reactants. Okay, so now look how many electrons are involving here. Plus 2 is converting into 0, it means 2 electrons. This N value is also fixed. Okay, so now you are going to calculate standard electrode potential, that minus this thing. So if more concentration of product is there, what I am saying, more is the concentration of product, this value becomes bigger, so that big value is removed from this. It means this potential value will be less. Do you got what I am saying? They are saying which of the cell is having maximum EMF. So this should be maximum. It means this value should be minimum, because minus symbol is there now. So it should be minimum. So in order to make this minimum, what are the possible way we have? Tell me. Here it should be, this value should be less. It means product concentration should be less and reactant concentration should be more. Okay, so it means write for this Mg plus Cl2 converting into MgCl2 plus 2 chloride ions. So now what is this thing we will get here? E cell equals to E naught cell minus 0.059 by 2 log products are how much? What are the things? Mg plus 2 ion concentration, Cl minus chloride ion concentration. So both of them are ions only, product side. So now tell me, this concentration value should be now least, then we can get a greater electrode potential. Now tell me, what is the proper answer here we can go with? Both ions should be minimum concentration it should have. See, here we have 0.01, chloride ion concentration is 1 molar. Here it is 1 molar, this is 0.01. Okay, this is bigger values here. Here both of them are smaller values only. So what is the suitable? D. That's it. Is this clear what we are doing? That's it. Okay, now I will give you few more questions. You just practice them. Try to answer me in the next class. This question. Okay, and this question. The one which I have given previously, this one. 3 questions as a homework. Okay, you just try them, and if you have any confusion you can ask me. Okay, so those who are in online, so thanks for watching. If you have any doubts, please mention in the chat box, we will discuss it. Okay, thank you.